Okay, we are going to continue chapter number 4, network layer, the data plane. Okay, so in last class we have discussed IP version 4 addressing, and then we discussed DCP protocol and how net works. So today we are going to discuss the data plane for SDN network, and then we will like to start chapter number 4, control plane. And by starting the control plane, we would like to discuss and describe the link state routing protocol. So we are going to, as we are going to discuss the data plane or the forwarding for SDN based network. So we will discuss match action in OpenFlow example. Now, as we know that the network layer, it has two components. One is called data plane and another is called control plane. Okay, so what is the network layer? It has two functionality. One is called data plane and other is called control plane. Okay, so the data plane, basically when a data packet arrives at a switch, so the data plane examines the header in the data packet. For example, if the header contains the IP address 0111, destination IP address, then the router has a table, a forwarding table. So the data plane search this destination IP address in the forwarding table. If the matching is found, okay, then the data packet is forwarded as per the action or as per the corresponding action or as per the corresponding route, as per corresponding the destination output port specified in the forwarding table. The packet is forwarded on that link or on that port. So the data plane, it is local. Each switch has a data plane. Okay, so it determines how the datagram arriving on an input port should be forwarded to the output port. So its functionality is about the forwarding. Now we have discussed that control plane, it basically involves to build up the forwarding table on each router. Okay, so the control plane, it is of two types. One is called traditional routing protocol and one is called SDN. That is, in traditional routing protocol, each switch has control plane, and each switch, the control plane of each switch communicates with the rest of the with the control plane of the rest of the switches, and then it builds up this forwarding table. Okay, but in SDN we have a centralized control plane. That is, there is a centralized control plane, and centralized control plane builds the forwarding table for each and every switch. Okay, so up to now we have discussed the data plane of traditional routing protocol, and now we are going to discuss the data plane of SDN. Okay, so we know that per router control plane, that in each switch we have a control plane, and the control plane of each switch, it communicates with the control plane of the rest of the switches, and then it builds up this forwarding table. So this is distributed in nature. Okay, but however in the SDN we have a centralized control plane. Like, the control plane is implemented at a centralized server. This is called remote controller, and this control plane that is implemented here for each and every switch. So this control plane builds up the forwarding table, or it populate the forwarding table of each switch. So we can say that the control plane in SDN is centralized. Okay, so in SDN, each switch, it is connected with the controller. Each switch is connected with the controller. Okay, and each switch communicates with the controller by using a protocol. So normally this is we have a OpenFlow protocol is used usually. OpenFlow is a standard OpenFlow protocol, open source protocol. So the OpenFlow protocol is used for the communication between switch and SDN controller. Okay, so in SDN, when a data packet arrives, initially the switch table are empty. Okay, so when the switches are connected to the controller, so each switch periodically sends its link state information to the controller. So the controller has the whole network topology, whole network view. So when a packet arrives at a data plane and there is no entry in the forwarding table, then the switch forward that packet to the controller. Since controller has the whole network view, so it computes the path, and then the path is installed in the corresponding switches, not in all the switches. For example, if the path is passing through these three switches, then the path will be installed in these switches. Then the data packet is forwarded. Okay, so each switch is each switch is connected to the remote controller, and the remote controller in the centralized control plane, it populates the forwarding table at each switch. Okay, now we are going to discuss the data plane for the SDN. So as we have discussed that in the SDN, each switch is connected with the centralized controller. Okay, so each switch has a flow table, local table, as we have a forwarding table in the per router control plane, but here we call this as a local flow table. We call it as a local flow table. And in the per router control, we have discussed that it was a destination based, but here it is more general. You can see in the local flow table in the SDN, each switch has a local flow table. The forwarding table is called local flow table. Its structure is like this, that we have header, okay, we have counter, and we have action. The header is also called pattern. It is also called pattern. For example, if a packet arrives with the source address 12 and the destination address 354, so this is the header, this is called pattern. Okay, and if a packet arrives, this is an entry, this is called header. So if packet arrives with the source IP address 12 and destination 345, then the packet should be dropped. This is the action. This is the action. So each the flow table, it has three types of entry: header, action, counter. So header means the pattern. Okay, so for example, if the packet arrives with the source address 12 and with the destination 345, and the action means what should we do if this header is matched. If this header is matched for incoming packet, then what should be the action performed? The action could be drop, it should be forward, it should be modify, etc. Okay, and the next field is called counter. Counter, what does it mean? That how many packets have arrived on this switch, how many packets have arrived on this switch that has matched with this entry. For example, here we knew counter is equal to 5, so it means that up to now 5 packets has arrived on this switch, and these 5 packets has matched with this entry. That is, the packet has arrived with the source address 12 and destination 345, and they were dropped. So the 5 packets has arrived, and for them so it means that the 5 packets has arrived that has matched with this entry, so it is counter is equal to 5. Okay, so this counter is used that how many packets have up to now have arrived and has matched with this entry. So each time a packet arrives and that match with this entry, then and this action is performed, then the counter will be incremented. The counter is incremented. This is also called statistic. Okay, so in SDN, each router, it contains a flow table. Forwarding table, it is called flow table, or it is called local flow table. Okay, In this flow table, it contains three types of entry: header, counter, and action. Okay, header means the pattern. Okay, and action means whether when this header is matched or with this pattern is matched, then the packet should be either dropped, it should be forwarded, or it should be dropped. Okay, and counter means that how many packets has arrived that has matched with this pattern and this action is performed. For example, up to now counter is 5. It means that at this switch 5 packet has arrived which match with this source address 1 2 and destination 345 and that were dropped. If the next packet has arrived with the source address 1 2 with the destination is 345 and that packet is dropped, then the counter will be incremented by 6. So it shows that how many packets have arrived for this entry. Okay, that how many packets has arrived and that has matched with this entry. Okay, and this flow table, it is basically computed by the logically centralized controller, and the control plane is implemented here at the controller. So for the all switches there is a single control plane, and that single control plane is implemented on the controller. This centralized routing protocol, this is also called centralized, and it is distributed by logically centralized routing protocol. This control plane, it can be can be implemented on a single machine. You can see it can be implemented on a single machine or it can be implemented on many machines, but they all physical. For example, it is implemented on 5 machines, but these 5 machines will be logically appearing as a single machine, like we have cloud computing. Okay, so this is how it works. Now we are going that in more detail, that what is the flow. So basically flow is defined by header field. So header fields can be like source IP address, destination IP address, source port number, destination port number, etc. We will discuss it. Okay, this header is also called pattern. Okay, the generalized forwarding is simple packet handling rules. So in each packet, each entry, it has pattern or header. Okay, so the when a packet arrives, okay, then the header is examined, and if the header is matched with this pattern, this header, okay, the match value in the packet header fields. So when the packet is arrived, so the header value in the packet, they are matched with the header values here. If the packet match with any one of the entry, then the corresponding action is performed. Before and when the action is performed, then the counter is incremented. Okay, the action for the packet, it can be dropped, that when a packet match with this entry, it should be dropped, or it can be that forward. For example, if the packet match with this header, with this entry, then it should be forward to port number 2, for example. Okay, or modify match packet or send to controller. So these are the possible actions. We will discuss it each of them through an example. Okay, and priority, we can have that a packet can match with the more than one entry. Okay, then certain entry will have priority or others. Okay, so we can define the priority. Okay, so the priority is used in the case of disambiguate the overlapping pattern. Maybe a packet can match with the multiple headers, so we will take the one in the last. We have discussed the longest prefix matching, but this time we will assign the priority. The priority means that the highest priority will be the highest priority entry will be given more priority. Okay, and counter specify that how many bytes or how many packets have arrived that is matched with this entry. Okay, so each time a packet arrives and that match with this header and that action is performed, then this counter is incremented by 1. Okay, so basically you can see that the flow table, it basically in a router, it is computed by the controller, and it defines match action rule. If the packet header match with this header, then this action is performed. So we can see match and action rule. So if the packet arrives, then the packet header is matched with the header in the flow table. If the packet header match with any of the header in this table, then its corresponding action is performed. So we can see that the flow table in the SDN switch is a match plus action rule. Okay. Now what could be the pattern? Okay, what could be the pattern? The pattern could be, for example, like this way. You can see that we have source IP address 1 2 destination 345, then it should be dropped. And if the source is anyone and the destination is 34, then it should be forward to 2. You can see that if a packet arrives with the source address 1234 1234 and the destination address is 3456, so okay, so the source address is 1234 and the destination is 3456, so this packet match with this entry as well as with this entry, because in both have the destination 3456, so 34 he match here and 34 he match here. So whether this and the source address is 1234, so it also match with this entry and also match with this entry. So in this case, so whether the packet should be dropped or it should be forward to 2. So in this case, the packet match with these two entry, so we use normally priority. If the first rule has highest priority, so it should be dropped. It should be dropped. So when a packet match with more than 2 entries, then the action is performed for that entry which is the first in the table. So the priority is assigned like this way. Okay. Now we are going to discuss that what could be the pattern. Okay, what could be the header in the flow table, that we have discussed that this header or this pattern. Okay, so this pattern could be what more specifically. So the pattern, it could be what the pattern could include port switch port. Switch port means that when the packet arrives on this switch, so on which port it is arrived, input port number, this is called switch port number. Okay, when the packet arrives at this switch, so on which port number the packet has arrived. Okay, this is called switch port number. So switch port number, it is the port number on the switch, the physical port number, like for example port number 1, port number 5 of the switch. Okay, it can include VLAN ID. Okay, it can include MAC source address, it can include MAC destination address, it can include Ethernet type. Okay, it can include IP source address, IP destination address, IP port number, or IP protocol, IP TCP source port number and TCP destination port number. So this is basically defined in the OpenFlow specification. Okay, and the action, it can be one of these 5. It could be forward to port number, for example forward to port number 2, or it encapsulate and forward to controller, or it send to controller, or drop the packet, or send to normal processing, or modify the field. So we will discuss it. Okay, and statistic or counter. What does it mean? That when a packet arrives and it match with this header, with a particular header, then the particular action is performed, and each time when a packet arrives and it match with this header field and this action is performed, then this counter is incremented by 1. Or byte counter, that if the packet has 10 bytes, then it will be the counter will be incremented by 10 bytes. If the counter represents the byte counter, if the counter represents the packet counter, then when a packet arrives, okay, and it matches with this header entry and this action is performed, then the counter will be incremented by 1. Okay, so now we are going to discuss some example. Okay, that for example you can see that in this entry the port number is wildcard, the source maker is wildcard, etc., and the destination IP address is specified. Okay, so when a packet is arrived with on any port, with any source MAC address, with any destination MAC address, with any Ethernet type, with any VLAN ID from any IP source, but the destination address is 51608. Okay, then it should be forwarded to port number 6. It should be forwarded to port number 6. So this is the example of, because we are using only destination IP address, the decision is performed only on the destination IP address, so the rest of the fields, they will be kept wildcard, static. Okay, similarly you can see that this flow table, it can be used as a firewall. Why? For example, you can see that if a packet arrives with the destination port number 22, the TCP destination port is 22, then that packet should be dropped. Okay, so this is the functionality of firewall, that when we want this that certain traffic should be dropped. Okay, so the packet with this only consider the destination port number, the TCP destination port number 22. Okay, so the rest of the fields, they will be kept wildcard or static. So basically this entry says that any packet that with the destination port number 22, whatever are the rest of the values, like for whatever is the source IP address, whatever is the destination IP address, it should be dropped. Similarly, you can see that we can also have firewall rules based on source IP address. Okay, like for example, if a packet arrive with the source IP address this, then it should be dropped. Okay, so this is that the forwarding table in the SDN switch. It can be used as a forwarding table of a common router, or it can be used as a firewall to drop certain entries. Okay, similarly we can use the forwarding table as a layer 2 switching. Okay, we will discuss it in the chapter number 6. Okay, the layer 2 switching. So you can see that if a packet arrive with the source MAC address this, then it should be forwarded to the port number 3. Okay, so the rest of the fields, they are not checked. Okay, whatever are the rest of the field values, so only if the source MAC address is this one, then it should be forwarded to port number 3. Similarly, we can implement the NAT in the SDN as well. For example, if a packet arrive with the source IP address this, then this source IP address, it should be replaced by this IP address, and the source port number should be replaced with this port number, and then it should be forwarded. Okay, like NAT. Okay, so this entry, this is the modify is action. What modify action means? That if the packet arrives with the source IP address 128.119.1.2, then this action is performed. This action means that this source IP address in the packet, it will be replaced with the source IP with the source address 200.1.1.1, and the source port number will be set to 501. Okay, so OpenFlow is the basically match and action. The forwarding table, and it is stored in the form of match and action. Okay, match is a number. It can be the longest destination IP prefix matching, it can be switch. For example, we have discussed that it can be like destination longest prefix matching based on only destination IP address. Okay, or it can be like the switch, for example, only using the MAC addresses. The forwarding can be performed based on MAC addresses, specific MAC address. Okay, or it can be work as a firewall. For example, you can see that if you can see that in this case, you can see firewall, that if a packet arrive with the destination port number 22, then it should be dropped, or if the packet arrive with the IP source address this, then it should be dropped. So this is actually the functionality of firewall. So it can be implemented in the forwarding table. Okay, similarly we can use the forwarding table in SDN switch as a NAT as well, that we can take the we can perform the NAT functionality as well. How it is performed? So you can see, for example, if a packet arrives with the source address this, then it should be forwarded after modifying this. Modifying means that the source IP address is replaced by this one, and the source port number is replaced by this one. Okay, so now we are going to discuss an example of OpenFlow. Okay, so this is actually performed. Okay, you can see that, for example, here the host 6 want to send a packet, so I would like to put in example, and then we can discuss it. Okay,